Thank you everyone for being here. This is LibreOffice Bibisect for beginners. Let's start. All right, so who of you already knows Git? Most of you. For those of you who know, it's more than enough to say that when developers commit changes, they try to make it as small as possible, and they submit one after one after one, and we build a commit history. All good, right? Each change, committed change, has metadata, important metadata like contact information, date and time, who did it, some descriptions, but most importantly, what were the actual changes. We removed these lines, we added these other lines. Most of you already know this. That's Git in a nutshell. So now, what is bisecting? Who of you already know what bisecting is? Okay, who of you don't? Okay, so bisecting is actually very easy. I'm going to cover bisecting, not bisect yet, and it's pretty much easy. Once you get the algorithm, it's pretty simple. So we're going to look for a change, for a specific change within a commit history, within a timeline, right? We're going to assume that a change only is introduced once. If that change is introduced more than once, this doesn't work. You will get not necessarily false results, but misleading results maybe. So in this case, the blue circles are for commits that behave in an old way, and the red circles for commits that behave in a bad way. The ones that are filled in are behaviors that we already know, and the ones that are hollow, it means that we need to figure them out. We don't know. It's here for explanation purposes only, but we don't know. We're going to look for the first changed commit. Normally, we use this for regressions. And that's why you will see that instead of typing old or new, I'm going to refer them as good, the blue ones, or bad, the red ones. Okay? But Git bisect supports also the old and new syntax. Maybe we're looking for a change and not necessarily a bug. So we're going to split the problem in half, and we're going to search. We're going to build the LibreOffice. We're going to run it, and we're going to test it. In this case, we're going to find out that it's behaving correctly, according to the old behavior. And we know we have not reached that point in which the change was introduced, so we can safely assume that if we haven't reached that point, everything before is good. We're going to test the next one. We put ourselves, I didn't mention it, but the idea is to put in an intermediate commit. We're going to repeat the operation, okay? Once again, in an intermediate commit. This one is going to be bad. We have one left to go, and we found it. Now, you may notice that instead of testing the 8 commits, or 7, we did it in 3 steps. What's the formula, computer scientists? Log base 2 of n, right? So the beauty of bisecting is that you only need one more step as long as you duplicate the amount of commits in the history to search for. So even if you have 60,000 commits, you can make it in only 16 steps instead of 64,000 commits. Now, I'm going to show how bisecting looks like, not bisect yet, bisect using Git bisect, okay? Very quick mockup. First, the commands. You do Git bisect start, and then you need to tell Git the last known good and the first known bad commit. So what was the last blue ball, and what's the first known red ball, okay? And once Git bisect has that, it will automatically move us to some commit in the middle. We don't even care which one it is. We're just going to test, build, test, run. Build, run, and test, and mark. Build, run, and test, and mark, right? So we're going to loop maybe 4 times, 8 times, 12 times, 15 times. We need to be very, very careful. If we get distracted and we type good instead of bad for whatever reason, we end up in the wrong side of the bisection, and you get all your bisection goes down the drain. You need to start over. That's not exactly true, but I'm oversimplifying. And finally, you do git bisect reset. You may do it at the top just to make sure you clean up your environment, right? In this case, this is that Twinkle Twinkle Little Star song, the lyrics, and I'm going to look for the misspelled star word. Okay, I have a list of commits. I know that the first one is good, okay? And the most recent one is bad. So where did I make the change, right? So I'm going to do exactly what I just said. Git bisect start, git bisect good, this one, git bisect bad, this one. As soon as git bisect had both the last known good and the first known bad, it automatically moved us to a commit in the middle, right? So we are now here, and we're going to test it. We don't need to build anything because this is just a text file, but in reality, you will build, run, and test. And we can see that the one in the middle is incorrect. There's the bug. So we mark it as bad. Git bisect bad. We only said git bisect bad. Git bisect automatically moved us to another commit in the middle. We test. This one is good. We're going to type git bisect good. We do it. And once again, we iterate. Another one in the middle. This one is bad. We're going to type git bisect bad. The last one. And that one is good. And you can see how it starts figuring out, it starts narrowing it down until git bisect reaches a point in which there is a good commit immediately followed by a bad commit. And git bisect just says, hey, this one is a bad commit. D0432, this one is the first bad commit. And if we do git show, we can see that that's exactly where I introduce the change. All right? So that's git bisect, regular bisect. It works on a source code repository, easy peasy. Just halving and halving and halving until we get to the commit that we need.
You showed us a skip command.
I didn't show a skip.
Yes, you showed us in the possible commands initially that we can do good, bad, or skip.
Yes, you can do git bisect skip. I'm not going to show skip today, okay. But it's important. Thank you for mentioning it because, hold on, what happens if you are testing this one and it doesn't compile? What happens if instead of behaving like red, it behaves like green? What if it crashes before getting into the test? It's good only if it matches the good behavior. It's bad only if it matches the bad behavior. If it doesn't, it's a skip. Right? So, going back. Now, as you can imagine, applying git bisect to LibreOffice is very slow because I mentioned build, run, and test. And building takes a long time. I don't know how it works on your machines, but in a 32-core CPU that I tested, it took 40 minutes. Not all of us have those machines. Sometimes we have the CPUs, we don't have the RAM, or it's even configuration dependent. Let's say that it takes 1 hour. 60 minutes. And you spend 60 minutes compiling per iteration and 1 minute testing. That's 98% of the time compiling. Okay? And if you need to run 12 tests, that's 12 hours. Okay? Maybe Make can do some optimizations, but rough numbers. So what if we didn't have to do that? And that's where we have the very nice Bibisect repository created by the QA team. They have created an alternate repository. So we have a regular LibreOffice source code repository, and they have created an alternate repository with everything pre-compiled. The same commit history, but with every commit compiled, right? So old, new, Same here, the old and the new one. But everything is precompiled, right? Remember that Git assigns the IDs according to the content. Since this is different content, because one is source and the other is precompiled, the IDs will be different. So the commit messages will have a reference, just, like manually typed, to say which one it matches. Okay? It's a little bit more complex than that, but this is enough for explanation purposes. So far, so good? So, with this, we can just bisect over here. Exactly what we should have done over this side, we just do it right here. That's it. That's bisect. Thank you very much for attending. All right. So, bisect, binary bisect. In Spanish, we call it Bibisect because we speak how the words are written, but it comes from binary bisect, so I tend to say bisect in English. So, plain bisect over an alternate precompiled repository. That's it. Be sure to use the one for your operating system. Remember that Windows binaries cannot run Linux binaries and vice versa. So this means that there are multiple precompiled repositories per platform, Windows, Mac, and Linux. Be careful that the executable file is soffice, but it may be in a different location per commit. Okay? So it may change over time. Just make sure you find the right soffice before you do it. And also that you close your running instance of LibreOffice, because you may try to run soffice and it will bring up the currently running one. And you will be like, hey, what's happening? I'm not testing. I'm getting weird results. Yes, you're testing the same version all over, once and again, because it's the one that is running. So just close LibreOffice. There are other ways to do that, but for beginners, just close it. Now, one caveat. LibreOffice Bibisect repositories are huge. We're dealing with binaries here. The total amount of space taken by, if we had, one full repository, would be over 200 gigabytes. In my computer, it's about 240. So it can take resources from the servers. It can take a very good while to download. So what the QA team has done is to split them into versions. And this is a very specific caveat of LibreOffice's Bibisect. It's split by version, so you will have multiple repositories, so you can download only the ones that you need. Once you know the version, you can just download that one and run Bibisect over that repository, not have the full, history. 200 gigabytes, and you're only going to use 16 commits out of those, right? So if you download the Linux 64 7.2 Bibisect repository, you will get all the precompiled commit history from 7.1 to 7.2. What if we don't know which version to use? What if we don't know what is the version that introduces the bug? There is another repository called Linux 64 releases. I'm using the Linux example here. I'm using the Linux 64 example here. You can use this one. This one will contain one commit per public release. This is great work by the QA team. This is not my work, by the way. I must give kudos to the QA team for this.
Are these the first releases with a given number or the last releases with a given number?
All the releases with a given number. You will see it in a moment.
Okay.
Yeah. So one precompiled commit per public release. And once you find the faulty version, you just continue using the version-specific one. Okay? So the typical workflow is summarized as this. You first find the first bad release by cloning the Linux 64 releases repository and by bisecting over it. You might already have that if you have done a bisection in the past, okay? And then you will find the first bad binary commit by using the version-specific repository and bisecting over that. And then you can use git show by using the commit message on the source code to see which one is it, or what does it say, etc. Okay? Again, I'm oversimplifying. There are some situations which can require advanced manipulation, like what happens if a commit in the source code did not properly compile into the pre-compiled binary repository, or things like that. That's it. I have a demo prepared for you. You need to be patient because you will see me see the same thing like 25 times, okay? I'm going to use this commit, this book number from the TDF. I have already uploaded it here. This is doing a slide paste, scrolls all the way up to the slide pane. It was reported by all right, so let's see. It says that a presentation was attached. The instructions say open the attached presentation, select some slide. It doesn't matter which slide. Copy it. I'm going to summarize this as paste it after slide 19 and undo. Okay? And what happens is that the first few slides are visible instead of staying where it is. The presentation you will see has 20 slides. So it was, by the way, I gotta give kudos to you. This is a very nice bug report. Steps to reproduce, expected results, actual results, minimum file to reproduce the issue. Fantastic. So let's try it. Let's see.
I'm only doing that out of self-interest. Just for my own personal benefit. I don't care about all you guys.
All right, so.
Was it also a LibreOffice conference where you had to open up Impress?
No, that's a different.
All right, so I already have the file downloaded here. It's called many slides, just to save some time. First, we need to find the office location, and you can see that as of now, it's here. So I'm going to, where am I? I'm going to first do a git bisect reset. And I'm going to do a small pause. Instead of running this one, I'm going to go back to master just to show the bad behavior. All right? So I'm going to find, you can see how sometimes the S-Office binary can be in different locations, so that might be a good addition to any automation testing that you want to do, automated testing, add it to any script. I will use a bash script now, which is like this, okay, to run it, okay. So I'm going to copy slide 7. I'm going to paste it after slide 19 and undo. And what happens? It goes back to slide 1. That's the bug. It should stay where we are. Okay? It's easy. That's why I chose it, because it's easy. So we know.
I call that an annoyance.
Yeah, it is.
It's a bug, but
it's like a paper cut, right? So I'm going to do git bisect start. Git, I know master is bad.
I'll just say that when your presentation is heavy, and because Impress tends to become sluggish when you have slides with a lot of material on them, then the fact that it scrolls up, it takes you like half a minute just to scroll down.
So I'm going to, let's see what we have. You may notice that we have master, and at the very end, we have OpenOffice 3.3 tagged as oldest, so we can just use oldest as name. I'm going to check out oldest. I'm going to run it using my trick, so I don't have to worry about the Office location. We're actually running OpenOffice 3.3. OpenOffice.org. Sorry. Copy, paste, and undo. I will not go through the menus. I will just go Control, okay? So I do it fast. It worked. I pasted it, I undid it, and it worked. So we are now between a good and a bad version. Long as you know the full LibreOffice history, but we are between a good and a bad version. So git bisect good oldest. Or just git bisect good because we're already in oldest. And git automatically moved me to a commit in the middle. And now I don't care which one it is. I just build, test, and run, but I can skip the build part. We're going to try 6.1.0.2. I feel like a time traveler. 6.1.0.2. Copy, paste, undo. This one is good. And you can see, well, I will do one more and then comment on that. Okay, copy, paste, undo, bad, right? I need you to be my eyes, because if I get distracted, I may end up on the wrong side of the bisection. Okay, test, copy, paste, undo, bad. And you can see how, as I go through, the revision numbers are sort of halving. Good. Good. Bad. What version am I now? I don't care. Good. Roughly one step more. After this, so actually 2 steps. I don't know why they did it like this. Copy, paste, undo. Bad. Copy, paste, undo, bad. Right. We found out that the first bad version is 6.3.5.1. So we can go to the 6.3 repository. Okay? Yes, because this is 6.3.5, this is a backport. Yeah. We're going to find a commit for the backport, not for the main development tree. We were discussing this in some detail today. And so yeah, let's continue through that one. I'm going to start a new bisect because I'm in a different repository. Set, start. Of course, I need to be, what if both commits are good or both commits are bad, oldest and master? It means we're not in the right place. So I'm going to do git checkout master I'm going to test it. Copy, paste, undo. Bad. That's what we expect. Git checkout oldest. By the way, all the repositories have oldest as its name. So git log, all one line, and oldest. I think all of them have them. Test. Copy, paste, undo. Good. Okay, we're on the right track. 4,000 commits to check. Yes, but only 12 steps. Well, 13.
I think you're gonna get many goods now.
Sorry?
I think you're gonna get some, like 3 or 4 goods at least, because it's at the end of the.
Yeah, exactly, exactly. And yeah, I originally didn't think of this. I was getting good and good and good and good, and I was like, maybe I'm on the wrong side of the bisection. But no, later it made perfect sense. So it's good. Did I actually do it? Undo? Good.
You can just check the version.
Do you want to check the version?
Yeah, because if it's before 6.3.5, so this has to be good.
Yeah, this has to be good, exactly. I'm going to copy the slide, paste it, undo, good. Once again, good. Good. There's the bunch of goods. Good. So it's actually working as we expect, right? Bad. We found the first, not the first bad commit, but an instance of a bad commit. 6 steps to go after this one. Good. Bad. Bad. Good. So 3 more to go. Bad. Bad. And fingers crossed that I didn't mess it up. Good. All right. I know the commit SHA-1 by now by memory. So we found the first bad commit in the binary repository. The first bad commit in the binary repository is not this one, is 9E7049. If we do a git show, we're going to get exactly the same thing. You know, you can see that git bisect automatically gave us the description, so we didn't really need to do that git show. And if we go back to the source code, and I do a git show to that commit, it says it resolves, it was made by Cowland McNamara, resolves this. So he was trying to fix something, and this happened. But in the slide sorter, so it makes sense. Sometimes you get like, yeah, in writer, something's happening, and we're testing for Impress. Maybe we did something wrong. But in this case, it makes perfect sense. So yeah, we can now contact this guy, and ask him for help, maybe try to fix it ourselves, because now we know the exact code that was changed. In 15 minutes, we scanned through the whole LibreOffice history, through the whole source code, which is huge, by the way, and we pinpointed out sort of, let's say, in a moment in time and space. These are the links. Use the specific one. There are some times in which if you go too far in commit history, you need to use all libraries that might not be in your system anymore. So you might need to do some manual tweaking. My system is already prepared, but I needed to manually install a library. If not, it wouldn't have worked. So I'm just showing it how easy it is. Hopefully this is useful to you. And yeah, thank you very much. Comment from Chisco.
Just one note, I think once you have the commit hash, then it's a good practice to go to Baxilla and look, paste that commit hash and see